All right, let me see if I can do this in one take without a cat sitting on me or yelling at me or whatever. Today we're going to talk about integrals. We've done differentiation in multivariables. Now we have to do integrals. And we're going to start with the double integrals over rectangles. So, to remind you what it means to do a regular integral or one-dimensional integral, we have average Joe curve. We broke it up into little rectangles, and the integral represents the sum of all those rectangles, some of the area of those rectangles, as the width of the rectangles gets smaller and smaller and smaller. So we basically get the area if it's positive, we get negative the area if it's negative. So let's say we've got this curve, and if I integrate from 0 to a, it will give me a1 because that's positive the whole time. If I were to integrate from a to b, I would get negative the area of a2 because it's below the curve. If I integrate from 0 all the way to b, I get a1 minus a2. Also recall, if you integrate backwards, you get the opposite. So if I go, instead of going from 0 to a, I go from a to 0, you get negative a1. That's because the base of all your rectangles are actually of a negative length, which doesn't make sense, but that's how the mathematics works out. Okay, so now let's talk about double integrals. We're doing the same thing, though instead of finding area, we're going to find volume. So when we integrate over a rectangle, we'll get the volume under the surface. So let's see how it goes. So here's my surface. It's x squared y minus xy squared plus 10. I went ahead and added a 10 to make sure this was positive the whole time. Otherwise, it would do the same trick that it did with regular integrals, where it adds what's on top and subtracts what's on bottom. So let's integrate this. It looks like my y is going from 0 to 3, and my x is going from, oh, no, y is going from 0 to 2, x is going from 0 to 3. So this is how we would look at this. We would say I'm integrating over this region. I'm integrating with respect to x, with respect to y. I define the region to be between 0 and 2, x is between 0 and 2, and y is between 0 and 3. So this dx means I'm going to integrate with respect to x first. So that's why I put the limits of my x on this first integral. And integrate with respect to y, put that on the second integral. Think of these integrals as parentheses. You're going to work from the inside out. So think about it this way. I'm going to ignore all this dy and this integral 0 to 3 at first. I'm going to evaluate this crap on the inside. And just like with the derivatives, if I'm integrating with respect to x, anything besides x is considered a constant. So here y is just a constant. So this is normal power rule, not too big. We're going to add x cubed over 3. This will be x squared over 2, and then it'll be 10x. Oh, and if you integrate over rectangle, order doesn't matter. So I could also do it this way if I wanted to. Sorry, that kind of came out of the blue. I thought I was going to actually work the integral here. So order doesn't matter. If you're over a rectangle, you should pick the one that's easiest. I'll show you a good example of that in a second. But first, we're going to do this one. So I'm going to integrate with respect to x first. So I get x cubed over 3 times a y, x squared over 2 times y cubed plus 10x. Just like normal integration, I'm going to plug the 2 in and then plug the 0 in. So here's with the 2 in it, here's with the 0 in it. Yay, zeros are wonderful. They will go away. Simplify all that crap. I get 8y over cubed minus 4y cubed over 2 plus 20. Give me the 20. Now, this looks like a normal integration problem. I'm going to integrate with respect to y. This will give me y squared over 2, but that'll cancel and give me a 4. I'll get y to the 4th over 4. That'll cancel. Then I'll get it to, okay, so this is what I'm going to get. I plug in the 3 and then plug in the 0. The zeros go away. Oh, that should have been a 0. We'll pretend that's a 0. This is all that survives, and when you simplify, you get 31.5. So that's not too bad. Nice polynomial thing. Order doesn't matter. Go either way. Let's look at something a little bit different. Suppose we have y times sine of xy. That's a picture of my surface. It's kind of crazy. It looks like I've got positives and negatives, so I don't know what the answer is going to be. We'll just have to check it out. The rectangle I care about is x is between 1 and 2, y is between 0 and pi. This is just a more compact way of writing all this crap. Now, if I were to integrate with respect to y first, this is going to be gross. Remember, if you've got y times sine of some constant times y, you would have to integrate this by parts. Whereas if I integrate with respect to x first, it's much easier. So, and the coefficient of my x is y, which is sitting out here. So it's like a little baby substitution problem. So I'm integrating over my area. So I'm going to integrate with respect to x first because it's easier. So x goes from 1 to 2 and y goes from 0 to pi. I tend not to put those parentheses around. I did it on the first problem just to kind of help you see it, but to me they kind of get in the way. But if you had trouble, definitely put parentheses around it. So I'm going to integrate with respect to x. So I have constant times sine of constant x. The derivative of the inside is sitting here on the outside. So the integral of sine of yx times y is just going to be negative cosine of xy. So now I've integrated. I need to plug in the 2, then plug in the 1. So there I get 2 and there's a 1. Now I integrate this. So I've got negative cosine of 2y plus cosine of y. Integrating this, I'm going to have to divide by the 2. And I get negative 1/2 sine of 2y plus sine of y. Sine of pi and sine of 2 pi and sine of 0, all that's 0. So this answer is 0. I always find it a little annoying when I go through all this work and then I end up with a 0 as an answer. But hey, zeros are cool. So that's it. So when you are integrating these things, some of the rules of integration are gonna come back up. I didn't give you anything really gross in your homework. You don't have to do like trig substitutions, but make sure you remember how to do not partial fractions. Make sure you know how to do integration by parts. I think there might be one of those on there. Make sure you remember how to do integration by substitution. And remember your rules. And that's about it. Good luck.